Welcome to my live. It's a differentiation next part of Australian curriculum. Okay, so we'll start. I'll share the screen. Hello, how are you? I'm good. I'm good. So, what was your maths result? I think you must get the result or no? Okay, 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 okay. So, I think we are stuck in differentiation. Am I right? It's Lavana. I'm sharing the notes. Most open recent STEM SAT demo 7th Maths. I'm sharing my screen. Just give me 1 second. Okay. So which is circle geometry? It is it's demo. It's demo 11.6 indefinite integral. So I think we are in 8 JKL. It's on April 11th. Okay. Okay. So we are at piecewise defined functions. Okay, let's go a little bit differentiability. Okay, okay. So let's enable my live session. So here I'm sharing my screen to my live class, which is about this particular window, not entire full screen share. Okay. Okay, so this is my live session of the differentiability. It's 8L of the Cambridge textbook. I'm just, yeah, it's a full screen now. Let's minimize. Okay. So I said, can you please what you're saying? Yes. Okay. So I will speak up. I will speak up. I will raise my voice. Okay. 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 Welcome to differentiability. I said, what is this concept? I think I shared in the last class my childhood memory. So CD is an expensive continuous differentiability. Continuous function may not be differentiable. But DC is easy, so every differentiable function is continuous. Okay. And differentiable means the function is smooth. Differentiability means the function is smooth. There is no sharp corner. So these are the sharp corners. There is no such a sharp corner. If there is a sharp corner, so there are more than one tangents will be formed. If more than one tangent lines will form, then more than one slopes will contain. And the slope is a limit formula. So for every limit, there is only one answer. There is no dual or more than one limit will come to one function. So that is a problem. Clear? So now, just piecewise defined functions. Piecewise defined function means it will be defined in the domain with pieces. See, what is this? Until 1 less than or equals to 1 means from the left side of the 1, so your function, your graph is x square minus 1. Okay. And after 1 and at 1, your graph is 2x minus 2. So what is this graph? X square minus 1. Do you know what is the graph representation? Parabola. It's a parabola. See, until 1, it's a parabola. Until 1, it's a parabola. And after 1 and at 1, it is, what is this next one? 2x minus 2. What is its graphical representation? A straight line. This is a straight line. Okay, so it is piecewise. It is piecewise. So if one can ask the the analysis of a function at particular point, then we have to go and which domain and where it's located and what is its function, and we have to do that. Okay, because sometimes all functions, it's not a guarantee that they should lie on the same function representation. So according to the situation, the function might be changed. So that is the way. And if it is continuous in this break, so this is a break point. This is a breakthrough of this function. So at that point, we have to check it properly. See, because it is a parabola, it is a polynomial. It is polynomial is every polynomial is differentiable. Every polynomial is continuous. There is no comment about that because they are smooth functions. Straight lines are also very smooth, simple functions, no problem. But wherever they join, so we have to concentrate at that particular point particularly. Okay. Okay. So next, that is the thing here. So the graph is continuous because two pieces join at 1 comma 0. So left is continuous, the right is continuous. Are they joining in the same point or not? So here they are joining at same point means here x equals to 1. So we have to substitute x equals to 1 in the both the functions. And what about f of 1? We have to look at 3. Okay, so left of the function is x square minus 1. So when x equals to 1, its value is 0. Okay, and f of 1, so it is upon at x equals to 1, it is 2 minus 2 will be 0. This is 0, this is 0, and the right side is also 0. All are zeros, means the function is joint at 1 comma 0. Okay, then it is continuous, there is no problem. And accordingly, so we can make the differentiation. Okay, how can we do the differentiation? Differentiation is the next thing. So less than 1, okay, continuous. Greater than 1, okay, continuous. Equals to 1, we have to think differentiability differently. Okay, so less than 1, x square minus 1 derivative is 2x. Greater than 1, x square minus 2x minus 1 derivative is 2. So it is about less than 1 and greater than 1. But what about joint? Okay, so we can see from this that when two joints, they do show the same gradient 2. So x equals to 1, it is less than 1 and it is greater than 1. So if you take x equals to 1, so that is only here only. So if it is equals to 1, they are 2. So 2x equals to 2 and 2 equals to 2. So therefore it is differentiable also, because here the function is very smooth, so the function is differentiable. So the function piecewise fully also differentiable, and f dash 1 is equals to 2. This is a big noise in this differentiation, because if the functions are straightforward, then no problem. This is just like a surgical operation. Okay, it is at x equals to 1, so you are bleeding at x equals to 1, so we have to open up and what happening there, and we have to see. If everything is okay, then we can tie up, otherwise we have to open up. Is it clear? Okay, so this is the way, this is the way. So whenever there is a joint is there, so we have to take care a lot. Okay, so here joints are different, differentiability. So here function gone, its continuity jump, not continuous, not continuous. I said every differentiable is function continuous. If it is not continuous, then not differentiable. Then it is not differentiable. See, it is a logic. If P implies Q, in mathematics statements, you can see if P implies Q, then negation Q implies negation P. This is the logic. Negation Q implies negation P. It is the most important thing. Okay, so if it is differentiable, it implies continuity, but then the same thing, non-continuity implies non-differentiability also. Okay, so with the graph we can comment directly, but Mathematically, we have to go with line by line. Okay, so here it is smooth. See here, I think 0 is the issue for this function. So if you see, this is the function. This is the function having problem at x less than 0, it is 1. X less than 0, it is 1. X less than 0, it is, what is, okay, sorry, the function is different. That's the derivative. So the function is b, the function is x less than 0, y equals to x greater than 0, x minus x square. See, whenever x less than, this is y is equals to x cross. And when x greater than 1, it is y is equals to x minus x square. Okay, x minus x square. And here the function is different. On the left side is different and the right side is different. And we have to concentrate it is the point at volt. Okay, so at x equals to 0, there is a nuisance. And now we have to think, he might give where is x equals to, he made this the upper function is x. So here the red function is right. Okay, so the red is joint with this, the red is joint with this only. Okay, and here and the right side, blue color is right side, goes like this. Okay, so it is continuous, the continuous, it is continuous. Continuous may not imply differentiability, we have to think again now. So now for the differentiability, you have to do the derivative. So its derivative is 1, x derivative is 1, and its derivative is 1 minus 2x. 1 minus 2x. Here written the same thing. Its derivative is 1 and 1 minus 2x. So you can see it is 1 and 1 minus 2x. At x equals to 0, its derivative must be 1. But x equals to 0, what happens? Here you have to substitute x equals to 0. So when you substitute x equals to 0, you will get 1 minus 2x is equals to 1 minus 0 is equals to 1. So its derivative is 1 at x equals to 0. So therefore the function is defined. Clear? So you have to be concentrate carefully. Should be concentrate carefully. So now they are the functions HL, IJKL. So it's last chapter, I think. Okay. To state whether if each function f of x is continuous at x equals to 0 and x equals to 2, and whether it is differentiable, smooth or no. Can you please comment at x equals to 0? Is it continuous? Because there is no break. At x equals to 2, is it continuous? But if it is continuous, we have to think. Okay, so for x less than 0, x equals 0, x greater than 0. Okay, so graphically I can comment because the function is not given. So is it smooth at x equals to 0 or no? It is yes, therefore differentiability is also yes. This understanding is most important. Most of students they don't understand that graphically in India what happens, we use only numerical oriented problems. Derivative, evaluate. If you give the graphical knowledge, one can understand very easy. Can you see? So at x equals to 0, this is x equals to 0. Okay, is this continuous? So at 0, the continuous. So at 2, is it continuous? Yes, continuous. At 0, is it differentiable? Smooth or no? Yes, differentiable. At 2, is it differentiable? Is it smooth? No, it's not differentiable. That's it. Okay. So it is a main observation. Mathematically, we can understand. And now, what happens at x equals to 0? Is it continuous? No, it is CTS is no. At x equals to 2, is it continuous? Yes, very good. At x equals to 2, is it differentiability? No, as no continuous implies no differentiability. Nothing to think about that. Okay. And at x equals to 2, it is smooth. Therefore, it is yes. Okay. So if yes, we have to think about the smooth. If it is not continuous, then it is not differentiable. Nothing. Okay. So next D. So at x equals to 0, is it continuous? So this is no, therefore by default differentiability also no. Okay. So at x equals to 2, is it continuous? Is it differentiable? Why? It's a sharp corner. It's not smooth. Right. Thank you. Similarly, sketch these graphs. So you have to sketch and you have to think. Okay. So this will give a lot of knowledge for the students to gain what are the basic functions and what how we have to plot. This is the most important. Okay. So here the function is at x equals to 1. This is 1. At left it is parabola. Do you know the parabola graph is like this? Parabola y equals to x square particularly. Okay. So until left and equals to 1, it is parabola. So means it is your graph is like this. Okay. And after that it is 2x minus 1. 2x minus 1 at x equals to 1, it is touching. At x equals to 1, it is 2x minus 1 equals to 1 only. At x equals to 2, what happens at x equals to 2? What is the value at x equals to 2? What is the value of the right function when x equals to 2? 2 to the 4, 3. So make, now come to here, it is 2, it is 3. So I'm taking the overlapping graph, no problem, try to understand. So here it is x equals to 2, the value is 3. So means you have to make a straight line like this. Okay. So the function is continuous because there is no break. The function is continuous. It is okay. And what explain why f dash is 2x. So less than or equals to its derivative is 2x, and greater than 1 its derivative is 2. 2x derivative is 2. And at x equals to 1, here we have to substitute in the top only 2x into 2 into 1, which is equals to 2. So f dash 1 is equals to 2. Is it clear? I will explain once again. I will explain once again. See here, less than or equals to, keep less than only. Okay. At less than, x square derivative is 2x. Greater than 1, 2x minus 1, 2. It's 2x minus 1. Its derivative is 2. 2x minus 1, derivative is 2. So at x equals to 1, what happens? In this derivative, you have to put here x equals to 1. Okay. At x equals to 1, it is 2. Its value is 2. So therefore, f dash 1 is equals to 2. It is f dash 1. F dash 1. Put x equals to 1. If you are getting the same values, it is differentiable at x equals to 2. Okay. So f dash 1 is equals to 2. Okay. See, you have to think. We can go to Desmos. How this? I think this graphing is very clear to you. How I plot question 2a. Is it clear? So next, you have to plot these two. Okay. So here, sketch each function. So you should know the sketching of. I think we learned the sketching of parabolas in depth. Okay. So there is a turning point, parabola upward, downward. Okay. left, right, each and everything will end. What about the special functions? Mod x plus 2. So it is mod x plus 2. Do you know how to plot it? So let's let's go. Let me go with the go with online. Okay. For that, just I'm changing my stream of live session. Give me some here in the live session. I'm sharing my entire screen. So now we can go to Desmos. It's a open source. You can use it online. So it is a Desmos graphing. So here, can you see mod X? I want to see the how to understand the graphing knowledge. What about mod X? What is the graph of mod X? Can you see the graph of mod X? Yeah. So whenever I change the screen to live session, it goes brick because I changed it in the live session. That is the issue. Is it clear? The two lives. Can you see my top right buttons, right menus with the two recordings? One is going to the live session and one is coming to the meet session. Okay, so that's why it could be up here like this. So here it is. So can you see mod X graph? Can you see the mod X graph? So what about the graph of mod X plus 2? Very good. Mod x plus 2, it's going to left. Okay, it's going to left. Thank you. Very good. Very good. And one more is mod x plus 2. It is up. Okay, so here it is the up. So here it is mod x. Okay, and it is moves to the left. When it is with touch with mod, it is just like a graph of f of x plus a. F of x plus a units left side. Okay, f of x minus a units right side, and here f of x of plus a. So this is different. So graph entirely shifts upward or downward. For plus a it is upward, for negative it is downward. Okay, so I'm drawing these two. So what is our question? Our question is this: sketch the each function state x is not continuous and not differentiable. So let's check the first one. So mod x plus 2, is it continuous? Yes, the student gave the answer. It is continuous at x plus 2, mod x plus 2. So what is the noise of the function? What is the noise? What is the problem for this function? Minus 2. So this is a noise. It is a noise. It is a noise. Here the behavior is not normal. It's an abnormal behavior. So it is a sharp corner, but the graph is continuous, no problem. Therefore, f of x is continuous. But when you see the sharp corner, so that x equals to minus 2, it is not continuous. It is not differentiable. Okay. So we can say for this function, continuous is okay, but differentiability is not okay. Okay. And similar, you can check mod x plus 2. Please comment where its differentiability is problem. X equals 0, 0. See, we have to generally we have to give the point of the domains only. So it is x equals to 0. Don't confuse the 2 is appearing there, so it is x equals to 2. It is not x equals to 2. It is x equals to, because that is a domain. No? So in if a function, how can you comment? So you have to think about the domain. Range value we can't control. Okay, range values could come. So whatever, see, f is increasing at this particular point, f is decreasing at this particular point, f is stable at this particular point. So you can give the answers to the given domain points only. So that's why. So majorly the question will be about the domain points. Clear? So here it is differentiable at x is equals to -2 for this function. So it is not differentiable at xc. What is asking x equals to? So here it is continuous but not differentiable at x is equals to 0. See, wherever you can see the question, he will ask x equals to, x equals to, x equals to, x equals to. No one is asked about y. Okay, so that's the issue. And even in the question also, the question is asked about x equals to, x equals to. When the domain is asked, the questions will be asked about your domain. See, if I give a question paper, okay, if I don't give this question from the syllabus, will you ask or no? Will you query? Will you raise a hand or no? Okay, so the syllabus has been given, so the test exam questions should be from that syllabus portion only. So if you ask any question out of that, it could be out of the syllabus. Okay. Even the next question, test each function of the continuity x equals to 1, and he makes the problem at x equals to 1. He makes the problem at x equals to 1. So if it is not different, not continuous, I'm writing aside, not continuous implies not differentiability. Not continuous implies not differentiable. That is a key point. And if it is continuous, we have to find the derivative. Find the derivative. Okay, find the derivative. So how can we check whether it is continuous or not? Substitute x equals to this joint point in both the left and right. Okay, so if you get the same answer, it is continuous. Can you substitute here? Is it continuous? The first A, is it continuous at x equals to 1? Can you comment? It's not continuous because 1 plus 1, 2 square is equals to 4 on the left side, and 1, it's a 4 minus 2 will be the 2 on the right side. It is not continuous. When it is not continuous, then it is not differentiability. Yeah. So next, can you comment about this function? Is it continuous? Very good. It is continuous. About this, is it continuous? Continuous. About this, is it continuous? Continue. So now, if it is not continuous, we can cross it not differentiable. But it is not differentiable, not continuous. If it is continuous, then we have to think a little bit carefully. So here, find out the derivative. Find out the derivative. What is the derivative? F dash x is equals to. Find the derivative. 3 minus 2x derivative is minus 2. What about the derivative of 1 upon x? One upon x, derivative of 1 upon x. Minus 1 by x square. Negative powers, power minus 1 minus 1 by x square. Is it clear? So here it is x less than 1, here it is x greater than or equals to 1. Okay. So at x equals to 1, what is f dash 1? Okay. At the left side, it is minus 2. But it is at x equals to 1, it is minus 1 on the right side. So it will not exist. Is it clear? Here put x equals to 1 both the cases. What is up if x less than 1? You will get minus 2. What is the right side? minus 1 upon x square. If you subtract x equals to 1, minus 1 upon 1 square, minus 1. Okay. Minus 2 is not equal to minus 1. I am writing here minus 2 is not equals to minus 1. So it is not differentiability. So you might get some sharp corner or plus minus infinity. Okay. So what is dash x here? Please comment of f dash x. Minus 2x. Next. No. Chain rule 2 into x minus 2 into x derivative is 1. X minus 2 derivative is 1. Is x greater than 1. Okay. So what happened when x equals to 1? One is minus 2, another one is minus 2. Therefore, it is okay. Therefore, it is okay. It is differentiable. Clear? Previously, it is not such a situation. Here it is minus 2 and it is minus 1. So that's wrong. So now we'll come to here again. It is what is the derivative here? F dash x is equals to what is x minus 1 whole cube derivative? Whole square chain rule and x derivative is 1. It is 2 into x minus 1 whole power minus 1. It's a 2 minus 1. So 1 x greater than 1. So here f dash 1 is equals to both are zeros. Okay, so it is differentiable. You have to revise. See, if you don't remember the derivative formulas, if you look up those formulas after 1 week or 10 days, even after 2 3 days, also you will not remember it. Is okay. You have to watch it regularly for continuous period of time so that it will be permanently stored in your mind. Okay, is it clear? Are you understanding my comment? If you want to remember those derivatives and all for certain time, you have to regularly practice. After that, they will remember. They will permanent practice at your mind. Then only you can give. Okay, and you are in the 11th standard, and you should not skip or miss the days of revision. Just daily 3 to 4 minutes. Just have a look into it. What is the derivatives and all. So you have to remember. Okay. So now it is semicircle. I know this equation. It is semicircle. It is semicircle. So for x less than it is one kind of circle, one is greater than it is one another kind of circle. Okay. I want to read. I want to plot this graph. I want to plot this graph. Okay. How can we do this? So I'm going to the same. So under root of Desmos is one of the best helpful topic here. Square root of. So what is the function? It is 1 minus x plus 1 whole square. 1 minus of x plus 1 whole square. Okay. So you can see this is a graph. It's clear. The next one is enter control C, and next one is here. It is minus. I think you can check here to x both are minus. Okay, and it is minus 2 to 0 is one graph, and 0 to 2 is another case. So this is a graph. Left side is one graph, right side is one graph. This is your entire graph. And he's just commented about minus 2 to 2 only. Minus 2 to 2 only. This is your graph. So I'm taking this graph and coming back to here. Yeah. So this is the graph of the required function. So can you read sketch? So he just simply asked to sketch. Okay, but how can we draw it? There is a Desmos, okay, but how can we draw it? He given a hint, just to make a square. If you do, it is y is equals to under root of 1 minus of x plus 1 whole square. It is squaring, it is y square is equals to 1 minus of x plus 1 whole square. It is y square, or it is x plus 1 whole square plus y square is equals to 1. So what is the equation? This equation is a circle equation. It is a circle equation. X plus 1 whole square plus y square is equals to 1. The center is, what is the center of the circle? This box. It is the center of the circle. Minus 1 comma 0. Not only now, this is a point he asked. It is not only x value. So here you have to go. It is minus 1 comma 0. This is your center of the circle, and radius is 1. So this length is 1. Okay, and again the right part of the function at 0, it is minus becomes, it is x minus 1, means the center is 1 comma 0 is your center. Okay, 1 comma 0 is center, and radius is 1. So this is the function. Clear? So now can you comment what is the noise of this function, where we have a noise of this function? There is a problem to this function. X equals to 0, that's right, x equals to 0. Okay, that's right. The student gives the answer x equals to 0 because it is a sharp corner. Okay, see how that magic is here. It is smooth, 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 and just at a, once it is touching and it is jumping. Okay, only at one point it is problem. Rest all points are okay. The problem is only at x equals to 0. Neither for the left of x equals to 0 nor for the right of x equals to 0. Only that particular point. In the left of x, we have uncountably, infinitely many points are there. For the right of the x also, immediately right of the x, there are infinitely many points. 0.001, 0.0000001, 0.00, times 0, 1. It will all will be the right side of the 0. The left side, it is minus 0.1, minus 0.005, minus 0.00000. If you one add one more 0, it will goes to in deep, in more nearest to the 0. Is it clear? The line is a magic line. It is not a simple line. Only the number line you can learn in the preschools and all. The number line is integers. After 1 it is 2. After 2 it is 3. But in the real line, there is no after 1. After 2. Okay. After 0.1. No. After 0.1 there are many things. Whatever you number say, in between those two numbers also uncountably many points are there. Okay, so such that is the magic of this function. Okay, so now we had to comment about, that's it, he asked me just plot it. So can you comment about this function with the, so whenever mod comes na, your differentiability guy. Okay, whenever mod comes, wherever that modulo becomes 0, then that point is not differentiable at 0. Okay, inside mod, what is the inside mod? So previously I want to go here. So here, what is the function is? Can you read this third A? Why? Where its differentiability failed? So wherever the internal part becoming 0 means x plus 2 is equals to 0, implies x is equals to minus 2. That is differentiability gone. Here mod x, so x is equals to 0. Differentiability gone. Is it clear? Okay. So wherever the modulo is there, internally the function wherever it becomes zero, it will go. So now come here. So mod of x square, where x square becomes zero, at x equals to zero. Okay. Where it is mod x cube, x equals to zero. Okay. What about mod x? It is x equals to zero. We'll plot all these graphs. Now it is cube root of x. Cube root of x. We have to think it. Cube root of x. It is danger function. It is not polynomial because its power is radical. Okay. Now let's plot the mod x square. Mod x square, you can get the graph of mod x square as there is a modulo function mod. Okay, x square. Oh, I'm wrong. I'm wrong. I'm wrong. I'm wrong. So this is mod x square. Huh. Is it smooth? It is smooth. Okay. It is smooth. It is differentiable at x equals to zero and continuous. Then I am wrong. So it is yes. It is mod x cube. So you can comment here. Still, it is continuous. Mod x cube. Can you see? I'm zooming, zooming, zooming. How the numbers are going? It is it is minus 0.10 power 8, 10 power minus 8, 10 power 9, and all, and all, and all. Okay, we are very, very, very near to the graph. It's zero. So it is smooth. So it is also smooth. Okay, so it is smooth even for this. Okay, so it is yes. And what about square root of mod x? Square root of mod x. Mod x means internally we have to move this power. Square root of mod x. Square root of mod x. So now we might get a problem. Can you see the graph? So can you see the graph? What is the graph? Only one vertical line. It is not vertical line. It is just like a parabola upward. There are two lines, but we have to zoom, zoom. Okay, we're going minus 1 lakh. Can you see the graph? Okay, so here it is sharp corner. Is it sharp corner or no? So we can't get the touch, we can't get the smoothness. Okay, so here it is very sharp. It's a sharp corner. It is, see, what is the number on the left side, right side? 10 to the power of minus 13. It is denominator. It is 0.13 zeros after 5. Okay. So in the top also 0 point. So we are very zoom. If you make minus 13, so you can get minus 14. Do it 15 million. Whenever I am increasing, one more 10 times deeper, deeper, deeper. Okay. So it is minus 20 times 0.000000000000000000002. That is such a point. It's a very, very closer to zero, but it is not zero. Okay, so it is not differentiable at x equals to zero. So it is yes, and this is no. sorry, this is no, this is no, and it's one third, a cube root of x, cube root of x. What is this cube root of x? It's x power cube root of x means 1 by 3. X power 1 by 3 is also same. X power 1 by 3 is also same. So I think I went thousands of miles between this 0 and next to 0. So what is this function? So this is a graph. Is it continuous? Yes. And given this point also, so the derivative here it is problem. So what is the derivative? Slope of the tangent line. So if I plot the tangent line, what happens? What is it? Vertical line. If that vertical line is having the slope, what is the slope of vertical line? What is the slope of vertical line? Infinite. Okay, it's infinite. It does not. It will not exist. Okay, so manually we can comment. So here it is x power 1 by 3. Its derivative y dash is equals to 1 by 3 x power minus 1. So minus 2 by 3. So it becomes denominator 1 by 3 into x power 2 by 3. So at x equals to 0, this function is not defined. When it comes to the denominator, at x equals to 0, it becomes 0 in the denominator. It is not possible. And here also you can give the derivative y dash is equals to root x derivative is 1 upon 2 root x, 1 upon 2 root mod x. Okay, and mod x derivative is 1, or mod x derivative at x equals to, no, there's no particular, so except 0. If you avoid 0, so its derivative is minus 1 is left and right is up. It's a piecewise function. You will get two functions. Okay. Mod x derivative I'm writing. But here at x equals to 0, it is not defined. So that's why these two functions are not differentiable at x equals to 0. This is quite important. For all technical mathematics, you can understand this concept. Okay. So with this, our chapter is completed. Congratulations. Let's clap. Okay. Finally, the differentiation is completed because we are learning its long days now. Okay. So sometimes, see, this is the thing you have to practice it clearly. In the next class, I will take a test on this chapter review exercises. Okay. I will take a test because almost it is 2.56, so it is almost 1 hour is reached. I think mom said that only 1 hour you're free. So in the next class, you try to get the derivatives. Okay, it is a revision type of the thing. So and cause the derivatives only you have to find the families. Here you have to do a reverse differentiation. Okay, whose derivative is this? I can say x cube plus 4x. Its derivative is this. If you take this is y is equals to, so it is 3x square plus 4 is the derivative. He is asking in the fourth question reverse functions, and here first derivative, second derivative. Okay, so is up to 1 to 6, and all points, all functions are questions, normals and tangents. You have to understand each and everything. Okay, revise this thing, and I will ask the questions from this so up to only these questions. There is no numerical change. Okay? I will ask the questions from this section only. Okay. So finally, there is a greater than plus means there is no further page. Okay. Congratulations. Congratulations. Okay. Your differentiation eighth chapter is completed. Differentiation is completed. Okay. So here in the next, before going to the next, I would like to stop my online live session. So think my screen is white. No, it is clear, my screen only. So this is my live session of the differentiation part 4, I think. Okay, so with this we completed the 11th standard differentiation of Australian curriculum, New South Wales. So here I'll stop here my screen presentation. Yeah, so this is a part of differentiation. So thank you here for the online session, students, and